Right, chapter 13, that's integration. Same as differentiation, the actual process of integration I'd say is relatively straightforward. If you've got something that you want to integrate, make sure it's in the index form, so you have a number, then your variable, and then a power. Increase the power by 1, and then divide by the new power. So ax to the power of n, increase it to n plus 1, and then divide by it. Just remember also you need the plus c, the constant of integration at the end, unless you're doing definite integration, which we'll go on to. Other thing that you'll do with integration is if you know the dy by dx function, the gradient function, and a pair of coordinates on the original function, so an x and a y on the original function, so that's called a pair, then you can find that original function by integrating it and then substituting in the pair of coordinates, the x and y, to solve for c. So if this was my gradient function and this was a point on the function, integrate that to get x cubed plus 2x squared plus c, and then to find this c I substitute in x equals 1 and y equals 5, and that gives me c equals 2, and then you just put that value of c into the y equals. So those are the basic things that you can do with it. Moving on to the intermediate stuff, we've got definite integration. Again, the process of integration, no more difficult, but there's just a few more stages. So you increase the power by 1, divide by the new power. And then if you're integrating between b and a, you put these square brackets and then b and a. That shows that you've integrated it, but you haven't yet substituted in the values. You substitute in all the values of a, which is the top one. So substitute those into x. And then do the same thing for b, and you find the difference. I've written minus there, it should be plus still. So yeah, substitute in a, substitute in b, and then do the first one, take away the second one. You can just be asked to do that on its own, but more likely you're going to be asked to do something to do with a graph. So what I've shown here is that same function that we've had here. I factorised it so that I could plot it or sketch it. And if you wanted to find out just an area between two x values of a and b, this is what it would look like. If the b was here and the a was there, you'd find that area. If you wanted to find this area, which is quite common, finding the area bounded by the curve and the x-axis, you'd use this as your value of b, 0 as your value of a. So you put in 0 into that, you'd get 0. You put minus 4 over 3 into that, take that away. And the thing to remember is that if it's underneath the x-axis, then it's going to come out to be negative. So if you've ever got something where, say you want to integrate between this value of a and here, and you want to find the total area, you have to split that up into the bit that's below the axis, work out that area, make it positive, and then the bit that's above the axis, work out that area, and just that's going to be positive already, and just add them together. But yeah, areas underneath the x-axis are negative when you do the integral. Last thing then for advanced is anything between a curve and a line. So instead of being between a curve and just the x-axis, as in this case, if you wanted to find that area, you'd just put in a and b into this, which you can also do on your calculator. If you want to find the area between a curve and a line, it's normally a little bit more geometric problem kind of territory. So here I haven't given any information here, it's just a kind of upside down quadratic, so it's going to be a minus x squared. If I wanted to work out this value of r, then first thing you want to do is find the points of intersection. So maybe I'll call those b and a. That's b, that's a. Find the points of intersection by putting the same way you find any points of intersection, by solving them simultaneously. So if you had an equation here, y equals something, and here you've got y equals k, you just equate those, find the values of b and a where they meet. Then you just want the x coordinates. So put in the x coordinates of b and a into the integral of the curve, And what you have to remember is when you do that, you always go straight down from the points. So if you put in here B, go straight down in a straight line. Same thing for A, and you're going to work out the area of everything to the left of, sorry, to the right of that line, the left of this line, and above the x-axis and below the curve. So it makes a little shape. If I only want R, I need to take away this rectangle at the bottom. Okay, but each question is different. So just look carefully at where you want to integrate between. So normally you want to find some points of intersection and then integrate between those. And then normally there's some kind of geometry going on. You have to take away a rectangle or a triangle or something. But you want to integrate between the curve where you want it. Here, sometimes you want the questions, it's not actually a difficult integration question, but sometimes they combine integration with differentiation in an awkward way. So here, if I was trying to integrate this curve between B and A, where they are the x coordinates of the turning points, so you see here that's the maximum or the local maximum for the cubic, this is the local minimum for the cubic. Sometimes they just give you the cubic and say what's this area between the two turning points. To do that, the first step is to find the turning points by doing differentiation, and that can mess people up when they've got to do differentiation and integration in the same question. Nowadays they tend to split that into two parts. They'll say find the turning points in part A, and then part B, find some area between the curve and whatever. But if they don't, I have seen questions where it's like 10 marks just this, but I think they've changed that since, that might have been a 2018, 2017 question. But if it mentions a turning point, you have to differentiate first and then look at what you've got. And if there's ever anything shaded in, more often than not, you're going to do some integration, unless everything's a straight line, in which case you don't need to. I think that is all. I'll just point out this again. Make sure it's in index form. Don't try and integrate the top of a fraction and then the bottom of a fraction and then just leave it. Make it into index form first. That is chapter 1 stuff. You go back and look at chapter 1 if you're having any trouble putting it into index form, because it's key for this and for differentiation. Alright, enjoy.